Okay, so I think we are live, Harsh. So welcome to the Quant University Summer School session, everyone. And as you all know, we have been hosting these Quant University summer sessions every Tuesday for the past close to a year or so. We started last summer when COVID-19 basically curtailed us to stay in our homes and basically do all the work from home. So I think we're kind of getting used to working from home, I guess, with all the liberties we've been having for the last year or so. And I've been seeing this whole transition as the traffic is increasing, as you're getting back to the city, the flights are getting full. So I think life is slowly returning back to normal. I hope you're all enjoying the transition so that you can go back to your restaurants and coffee shops and all the fun things you would do before COVID. So these Quant University sessions are a part of the schools we've been organizing, primarily focusing on the intersection of data science, machine learning, and finance. As you all know, my name is Sri Krishnamurthy. I run Quant University, and for the past 8 years, we've been looking at all these frontier areas and how these themes in machine learning, data science, and AI are influencing the various decisions which organizations in the financial services world are taking when they are making these technologies pragmatic and usable within the industry. And we have been inviting thought leaders, academics, practitioners to share what they've been working on and the best practices. And in that realm, we have been fortunate to have more than 40 speakers over the last year or so to come into our summer school and winter school and fall school. And so I think this is the wrong slide. Give me 1 second. So we've been hosting all these sessions, and on the responsible AI front, we've been looking at this whole theme of how do we address aspects of explainability? How do we address aspects of fairness? Because these are not just theoretical concepts. These are aspects which we have to pragmatically apply. And in that realm, we've been looking at various technologies which are being innovative and which are being invented as we speak, but also the pragmatic aspects on what does it mean to adopt these. So many of the courses we've been hosting are primarily looking at this whole area of what does it mean to pragmatically apply these technologies within the industry. And we've been hosting a bunch of courses. One, a boot camp on machine learning and AI for financial professionals. And another one is a series in AI risk. And we have three courses, one on risk and machine learning models, looking at stress testing, scenario testing, and evaluation. And another one on algorithmic auditing, primarily focused on what does it mean to comprehensively look at an audit for an algorithm. And the third one is model risk management for machine learning models, which, as you know, is becoming more and more important as we integrate practices of traditional model risk management, but now we are factoring in machine learning models. So Harsh and I, we have been having discussions, Harsh, Agus, and we've been having multiple discussions. And we thought that it would be an interesting session to kind of focus on this whole theme of fairness. And what does it mean when you talk about fairness? And as many of you know, when we started machine learning and we started working with data, the whole notion of fairness was not really in the top of the thing. We were always looking at performance, trying to get the numbers and seeing if we can match some of the benchmarks we already had with other models. And the focus was more to figure out, can we build better models? Can we build larger models? Can we build ensembles of different models to see if we can hit performance benchmarks? But when you talk about pragmatic application of many of these themes, you start looking at, well, what are the various groups which will be affected by the decisions of these algorithms? Should we optimize these algorithms for specific groups or collectively as the whole, all the groups? Should we be looking at what we already have in terms of data sets and then augmenting it with different kinds of potential scenarios? What are the possible impacts? And when we talk about building machine learning models, what does the features actually mean? Can we use certain kinds of features when we make these decisions? If we remove certain features, are we losing information, or are there correlated variables which already are capturing this information? So these are various kinds of discussions which are being discussed in the pragmatic world. And Hirsch and team at Wells Fargo have been doing a lot of research and contextualizing it with the decisions a company like Wells Fargo has to take, wherein millions of customers will potentially be impacted with algorithms which are used in financial decision making. So we thought we'll invite Hirsch to present some of the work they've been doing and talk about some of the pragmatic issues. And I kind of was very curious about like what the fairness discussion was within the Wells Fargo community, and I'm so glad that this white paper was published on Archive, and it kind of covered both the theoretical aspect but also many of the pragmatic aspects. So welcome, Hirsch. Thank you for taking time off your schedule and joining us at our Quant University session.
Thank you so much, Sri. This is it's a great honor to come here and talk about this. I'll just quickly caveat, anything that I say is basically my opinion and what I've learned about industry practices. Obviously, I can't disclose any sort of proprietary discussions within Wells Fargo, but happy to talk about my perspective, my opinion, and it's very informal. So people can sort of jump in and add color. And Sri, in particular, if you feel like I'm skipping over something, I'm assuming something about people's familiarity with these topics, please don't hesitate to jump in and add additional color.
Yeah, thank you so much, Harsh. So the stage is yours. So you can go ahead and present. So I'm going to make you the co-host. So take it away, Harsh.
So I just actually I don't have a lot of slides. I have just one slide. I'm gonna share my screen and show you guys the slide.
And for people who are joining in, if you have any questions, please use the Q&A panel to ask any questions. And this one is more of a discussion rather than theoretical thesis about like what fairness is about. So feel free to like comment and ask questions, and we'll try to keep it as interactive as possible.
Thank you, Sri. All right, so Sri, can you confirm you can see my
Yes, we
slide?
can see your screen. Yeah.
Okay, perfect. So before I jump into it, let me just quickly introduce myself. So I completed my PhD in statistics and joined the financial industry right around the time of the great financial crisis. So just as it was unfolding, and obviously that was a pretty crazy time to be in the financial industry. I worked on model development for various portfolios for capital planning, strategic planning, CCAR. I worked on some deposit modeling, some stress testing, and all of those kind of typical financial models. And then a couple of years ago, I kind of made a transition in two ways. One, I went from model development to model validation, which is what I'm doing now. And then I also moved a little bit away from financial models to mostly non-financial use cases. Things like marketing, underwriting, fraud detection, financial crimes detection, fair lending, and natural language processing type of use cases. So I'm definitely still learning. It's a very, very interesting space, and in particular when we talk about fairness, there's loads of law and case history that becomes relevant, and I'm by no means an expert in that. I'll just kind of present my point of view as a quant working in that space, and you quickly pick up a lot of these things. So let's first talk about fairness in banking. I'm not going to go into very, very technical details. I have a link up here on the screen. This is the paper that we have published on Archive. You can go in there and you can see a lot of details there. My hope is to keep this talk at a very high level, at a conceptual level, and provide some background on why these things matter and how to think about it. And then certainly the details you can look in the paper or several excellent resources in there. References to several excellent resources. So in banking, fairness and the framework for fairness is very, very heavily shaped by regulations and laws and regulatory guidance. And so it's very important to be aware of what regulatory guidance and laws are out there that impact the framework for fairness in banking. First of all, as most of you probably know, financial institutions are very, very heavily regulated, and appropriately so, right? I mean, what financial institutions do, it really matters, and it shapes not just individual lives, but it also potentially shapes the society for many generations. And what that means is financial institutions have an ability to create a lot of benefit for the society, but it can also create a lot of harm. And the perfect example of the harm that financial institutions can create is the harm that has resulted from redlining in the past, right? And a lot of people have done research that decades old redlining still has impact on families and societies and communities even today, right? So it's just an example of how far-reaching some of these impacts are. And so, that there's rightfully a lot of concern about misuse of AI in financial institutions. And banks don't have the luxury to keep trying it many, many times and get it right. It's not an agile kind of a mindset to move fast and break things. You can't do that. It's when you're dealing with livelihoods and such big social implications, you can't sort of get it wrong and then get it right. You have to try to get it right the first time. And you can see that, in terms of the regulations that are being put out there. Many of you might be familiar with the regulation that EU has proposed on AI. It's pretty far-reaching, and one of the high-risk use cases they talk about is lending, right? So that's right up there with many other high-risk use cases. When you look at kind of the details of the regulation that EU has, we have something on the US side which is similar in many respects, which is the model risk management guidance. It's not a regulation, it's not a law. It's a guidance that banking agencies have put forth in terms of how to regulate all kinds of models, not just machine learning, but all kinds of models. And to me, that guidance is called SR 11.7. It's model risk management guidance. It's a pretty short guidance. If you've not read it, I would highly recommend that you take some time. If you're interested in this topic of responsible AI, I would highly recommend that you take some time and read it. It's a pretty quick read. And to me, it's still the kind of the most general and yet practical document for managing AI risk. Now, I think the document itself, this SR 11.7 document that I talked about, it's a principles-based document. It doesn't talk about any specific use cases, and it's straightforward to talk about models and AI in that respect. But when it comes to regulation, I think it's a lot more straightforward to regulate specific use cases than try to regulate a technology, right? Because technology evolves very quickly, and so what the US regulators have focused on is look at specific use cases and try to regulate use cases. And the strongest fairness regulations in banking are applied to lending. Lending is by far the most sort of risky activity that banks do, which have fairness implications. And when I say lending, it starts from the marketing of credit products to underwriting, to account management, all the way to collections, right? So it's a full life cycle, and models are used at various parts of that life cycle. And so at all of those points, there is a risk of creating unfair impact. There are several regulations. There are state level regulations, there are local regulations, there are national regulations, but the one most important overarching regulation related to fairness in banking is the Equal Credit Opportunity Act and its implementing regulation, which is Regulation B. And it prohibits discrimination in credit transactions. And there are other federal regulations like the Fair Housing Act and UDAP, which are also relevant. And like I said, there are other state and local laws. So that's kind of a high level. Just the key point there is that there's a whole bunch of regulation, and rightly so. And lending is probably the most heavily regulated activity in banking. So then, let's dig a little bit deeper into kind of the notions of fairness that are sort of that provide a framework for lending. And there are two main notions of fairness. There is disparate treatment and disparate impact. Those are the two kind of unfair impacts or unfair biases that can happen in lending. Disparate treatment is when someone uses protected characteristics or their proxies for as explicit considerations in the decision-making process, right? And what are protected characteristics? These are things like age, race, gender, health, familial status, source of income, or other things like there are some local laws on use of criminal history, political affiliation. There are some laws regarding the use of whether or not someone has exercised their rights under consumer protection law. So there are some protected characteristics. We don't need to you don't need to know all of them because they vary by geography, but age, race, gender, health. These are pretty universal, right? So the couple of interesting things with regards to disparate treatment. One is, there are always some exceptions. So for example, age, it can be used to benefit senior citizens, and it can be used to avoid prospecting to minors, right? You don't want financial institutions to go and sell and market their products to underage minors, right? So in that sense, there are some exceptions to the explicit use of age. But by and large, these protected attributes should not be used at all in any decision making for lending. The other interesting thing is that there are some strong proxies for these protected attributes, which should also not be used. They're basically as bad as explicitly using the protected attribute. So these would be things like the language preference. If someone has a preference for interacting in Spanish, that tells you something about their demographics, about their gender, about their race, right? If someone is subscribing to men's health magazines, for example, then you can infer their gender from it. Or if someone is a minivan owner, then you can probably infer their familial status from it. If someone had a recent retirement, you can infer age from that, right? So there are all these other data elements which are not explicitly protected characteristics, but they are a close proxy of it. When it comes to geographical indicator, use of state level information is generally okay, but use of zip +4 information is generally prohibited, right? Because when you go to very granular geographical identification, then you are probably proxying for race. So there are, there's a kind of whole framework of, things which are sort of red flags or orange flags, which should not be used or only used in very, very limited circumstances for making credit decisions. So these are kind of all considered to be explicit, explicit discrimination and viewed as a disparate treatment. I think the interesting thing is with the use of alternative data, there are app providers who are starting to use all kinds of information that exists on the cell phone, right? So what kind of device someone is using, or their browsing history, or their calendar appointments. Some of these things have been used, not necessarily in the US jurisdiction, but in other jurisdictions where the laws are a little bit more relaxed. The online sort of app-based credit providers, they're using all kinds of information which could easily be proxy for demographics. So, I think even kind of the very simple question of is there or not disparate treatment, it becomes a lot more complex as you start including alternative data. All right, so then the next part is disparate impact. And disparate impact is when the discrimination is not that explicit, and it occurs when a lender applies racially or otherwise neutral policy or practice equally to all credit applicants, but the policy or practice disproportionately excludes or burdens certain persons on a prohibited basis, right? So for example, a lender's policy might be to deny loan applications for single family residences for less than a certain amount, right? If the residence is less than $60,000, then we are not going to make that loan, right? Now, this, on the face of it, it doesn't look like they are targeting any particular demographic group. It doesn't seem discriminatory on the face of it, but you could find out when you do the analysis that this minimum loan amount policy is disproportionately excluding potentially minority applicants from consideration because their income level is low, right? So even though the policy itself seems neutral, the impact of that policy is disproportionately harming certain protected groups, right? So that would be considered disparate impact. Now, the interesting thing about disparate impact is by itself, just because there is a disparate impact, that is not considered illegal. When it becomes illegal is, there are a couple more tests. So yes, there is a disparate impact, and then you need to test, is there a legitimate business reason for applying that policy, right? And in the context of models, it comes down to is there a substantial increase in predictive performance that is being attributed to a particular um, attribute? And if there is, if there is such an attribute which looks on its face neutral, but in fact does have disparate impact, you have to see, okay, what happens if we drop that attribute? If we drop that attribute, can we still get a reasonable performance? And if the performance drop is large and there is no other alternative attribute that can give a similar increase in performance, then it's generally considered okay to have that attribute in there. And to me, it's very interesting as a quant. It seems very interesting that there are certain things which are considered proxies of protected class, and they're absolutely not allowed, right? Because they're proxies, they're considered disparate treatment. They're absolutely not allowed, no matter what business justification you have for including them, or what kind of performance improvement you're getting from adding them. But then everything that falls outside of it, they could potentially be included in the model as long as there is a strong business justification, as long as there is a sufficiently high lift in predictive performance, and as long as there are no good alternatives to that data element. So to me, it creates kind of a discontinuity, and I think it's going to become very interesting as people start using more and more alternative data to see how kind of this discontinuity that exists due to the law, how that plays out, and how people kind of manage that and sort of utilize alternative data in a responsible way. So let me stop here. That's kind of the first thing that I wanted to discuss, is just an overview of regulations and frameworks that exist in lending, and in particular the distinction between disparate treatment and disparate impact. Yeah. Let me see,
I think there are a couple of comments here, Harsh. We can probably address them. So one comment is, shouldn't we be more concerned with how models are functioning with regard to outputs to measure disparate impact rather than the inputs? It's possible that if we take out explicit variables such as credit score or census block group, then the effect of these variables would be picked up by other proxy variables. So yeah, I think you covered some of it, but would you mind expanding a little more on that?
Yeah, I mean, so, disparate impact starts with impact, right? It starts with model output, and it could be that, you have nothing that's a proxy in there, but you're still getting disparate impact. It's just happening because, for example, something like income, right? So, and I'll give some more examples towards the later half of the call, but, something like income, it seems so relevant for making credit decisions, but you might realize that it's causing a disparate impact. And what most banks have done is, instead of using just income straight up, they'll do some feature engineering. They'll do debt to income, and then you find that you still get good predictive performance, and the disparate impact is lower, right? So there are these kinds of sort of heuristics that most banks have come up with regards to feature engineering, with regard to shape constraints, with regard to handling of missing data, and so on and so forth. And all of these are meant to sort of address disparate impact, even though they are using variables which are not proxies. Which you could say that they're quite justified from an economic intuition point of view, and yet because they cause disparate impact, there is further sort of adjustments that are done to be able to accommodate them in the model. But okay, the other thing to keep in mind is, the law does allow, even if there is a disparate impact, if there is a business necessity and if there is no other good alternative, the law does allow the use of models and rules that on the face of it causes a disparate impact. And that to me, that's very interesting, because if you look at some of the newer literature that's coming out in terms of AI fairness, they take a very, very absolute approach, right? I mean, they might put some constraint, okay, you cannot have more than this amount of disparate impact. You cannot have more than this amount of violation of demographic parity, or whatever fairness metric they use. So they're very absolute in that sense. And so it's kind of interesting to see how the existing law and some of these new ideas sort of interact with each other, and how the area evolves.
Absolutely, and I think that's a very interesting discussion, right? And that's why probably some of the context of the RFI, which was there, the five federal agencies put out the RFI. So I think that's one of the themes of the discussion, to basically kind of factor in how do we make this pragmatic when you think about applications and regulations, right? So I
Yeah.
think there's another comment which talks about fairness being an ethical issue and needs to be grounded with philosophical definitions um, as we get into the practical aspects of fairness in complex technologies like AI. And the question is, like, in banking, what is considered fair, and would customers agree to that definition of fairness? I know it's a philosophical discussion, but
Yeah.
how do you think about defining fairness and also disclosures about fairness in addition to the regulatory hood, if you will, in terms of like this is the absolute minimum that needs to be there, but
Yeah.
then what would be considered as fair from a customer's perspective?
Yeah. And it's a little bit funny. I think most banks would like nothing more than a black and white definition of fairness, right? It makes the job so much easier if there was a black and white definition of fairness, but there isn't, right? And honestly, I don't even know if regulators have the ability to make it black and white, right? A lot of it in reality is determined by lawsuits, right? Some lawsuit happens, and then some judge forms an opinion, and that becomes part of case law, and it kind of evolves that way, and it evolves as the society evolves, right? So it's really hard to sort of put down a specific definition. And when we say what would customer consider fair, even that different customers would probably consider different things fair, right? Different folks would have um, a different sort of expectation of fairness. The other thing to keep in mind is fairness is and I want to put it delicately, but there's always a cost to fairness, right? As you kind of raise your standard of fairness, you can expect that the models and the decision rules are going to become less predictive, which is absolutely right? If someone says that I want to use race to make my model more predictive, that's absolutely nuts. Even if it makes a model significantly more predictive, they should not be allowed to use that. But then as you start getting sort of deeper into things which are more sort of in the gray area, or arguably they have a strong economic intuition and basis for why it should be used for credit decision. I gave the example of income, right?
Mm-hmm.
Is it fair to use income or not? The reality is, in most cases, people would not use income. They would try to use something like debt to income. They would try to do some feature engineering to avoid using income, or at least to avoid having very, very high cutoffs on income, right? So the reality is the banks tend to be very, very conservative in these manners, and they try to kind of take the case law, and they try to put an additional layer of conservatism on top of it. So by and large, I feel like, at least when it comes to lending, they end up in a relatively conservative place when you compare them to fintechs or some of the newer entrants. Definitely so. But I don't suppose that they have the perfect answer, and I'm sure there are people who would disagree, and they would say that this is not fair enough. So this is going to be an ongoing discussion.
Absolutely, and I think that's something we've been hearing too. Whenever we have discussions, everybody's perspective is different, and I kind of give an example about the six blind men and the Indian elephant,
Yeah.
example, if you will. Like, it depends on where you're coming from and how you define certain things on your
Yeah.
perspective and how you've been conditioned. So how about we continue with the discussion? I know there are a couple more questions and comments, and we'll probably save the last 10 minutes for additional question and answers. But I'd love to continue the discussion. Yeah.
Yeah.
So feel free to let me
Yeah,
know.
absolutely. And I'm gonna go a little bit fast, because some of these start to get technical, and invite people to look at the paper in detail. But it's important sort of keep in mind the sources of bias and discrimination. And the reason it's interesting is, for a long time, people thought that bias can only come from data. Algorithms are kind of neutral, and it all comes from data. And that's not true. It certainly does come from data, and that's a big source of bias. But algorithms have a role to play as well. So I just quickly wanted to talk about it. And again, you can look at the details in the paper, but when you think of data, there are mainly two big sources of bias. One is that the outcome itself is historically biased, right? So when you look at sort of criminal justice type of data sets, You could argue that the ground truth in there itself is biased because it's based on human actions in the past. It's based on what society was doing, what society was like in the past. And so the actual ground truth information is biased. And that is very hard to work around. When the ground truth is biased, what do you do about it? It's just very, very hard. But there are people who have tried to come up with solutions to that, but I don't really think there's a very, very good solution to that. And I think that's where things like prohibiting explicit use of protected class, that's critically important, right? Things like those should just not be allowed. The other big source of bias from data is sampling, right? I mean, if you're sampling in an incorrect way, if you're only sampling the loans that were underwritten rather than all the loans that were considered, then you're going to automatically have a bias, and then the training data is not representative of the used population, and then that's going to be a big source of bias. In terms of algorithm, one big issue is that as you start using more flexible specifications, as you start using trees and very, very deep trees, you can easily start getting interaction of variables which are extremely complex and high dimensional, very, very hard for human beings to visualize, and they can easily serve as proxy for protected attributes, right? So that's how a more complex algorithm is able to come up with a closer proxy for protected attributes and demographics. The other well-known sort of effect of algorithms is something called bias amplification, where even if the data is fully representative, the model output can sort of amplify some biases when it comes to minority classes, right? So, for example, when you look at women and construction worker, that may be a rare combination, but even if you have data that's representative, what will tend to happen is, and you have a model that's trying to predict gender and it's trying to predict occupation, it'll tend to kind of predict women and construction worker as a combination a lot less frequently than what the training data had, right? So it's kind of amplifying the bias that already exists in the data. It's kind of a well-known effect of algorithms. And then there are sort of known effects in terms of early stopping, which is a commonly used regularization. If you're using early stopping, then you may not pick up sort of harder to learn features, right? So it comes into play when you have like various demographics in an image data set, right? And if Black and ethnic faces are less common in that data set, and if you do early stopping, then some of the features related to Black and ethnic data set may not be learned. They just learn later in the training process. That's how these algorithms work. And if you're over regularizing, if you're stopping the learning too early, then some of the characteristics of those sort of minority data elements will not be learned. So these are all sort of things that have been observed in algorithms and their regularization and so on. It's kind of a fascinating and evolving area. The key takeaway here is that it's not just data. It's frequently the data. It's very, very frequently the data that's the source of the bias, but it's not always. And algorithms can either amplify that bias or create new biases. All right. So then, the next thing I wanted to talk about is fairness metrics. How do you really measure fairness? And in banking, what has typically been used is demographic parity as kind of as a measure of fairness or discrimination. Recently, there's been kind of an explosion of research in fairness. People have come up with lots and lots of metrics around fairness. And I'm not going to go into the detail of all these different fairness metrics, but I just want to make 2 points here. So the first point is that a lot of these fairness metrics are incompatible. So you have mathematical proof that you cannot satisfy demographic parity and equal odds and an awareness all at the same time, right? So there's just a mathematical incompatibility between the different fairness metrics, and it kind of goes to the point of would the customers agree that we are being fair? And it's really hard, when you have a mathematical sort of impossibility of there being able to satisfy all the fairness definitions at the same time. I'm sure some people would always be dissatisfied. there's a very interesting case about the compass system, which was used in criminal justice, and there was a lot of back and forth between how it satisfied one definition of fairness but not the other. And so what do you do in those situations? It was an actual lawsuit where you had an algorithm that's used to determine parole, big impact on people's life. And you could look at it according to one definition of fairness, and it looked fair. And if you looked at it using a different definition of fairness, it looked unfair. And so what do you do there? And these are very, very hard questions. And they go to the I don't really have an answer. I don't have a answer of what is the right measure of fairness. All I can say is that in banking, there is a lot of case law, there's a lot of precedent, and regulators and courts have generally focused on sort of minimizing differences in favorable outcomes between groups, which is basically demographic parity, rather than focusing on balancing error rates, which is what some of the newer metrics like equal odds and equal opportunity try to do. So, that's my guess is for the foreseeable future, at least in banking, people will continue to use, at least in lending, I should say, people will continue to use demographic parity as kind of the main concept of fairness. And then, so with that, I wanted to move to how do you mitigate unfairness? What are the different things that you can do to mitigate unfairness? And I want to first talk about how it happens in big banks today. What's the current practice? Then I want to talk about some of the emerging ideas in this space, and then how to find a middle ground between what's current practice versus some of the emerging ideas. All right. So, with regards to what's happening today, obviously anything related to protected class attributes, that's just absolutely not allowed to be used. There's access control, and the data is protected with many layers of controls, and so the model developers simply don't have access to some of the protected class attributes. And usually the compliance teams in large banks also maintain a list of sort of they have a list of red attributes which can never be used, and then they have a list of sort of orange attributes or attributes which are extremely risky. They would generally be considered proxies of protected class attributes, but there may be sort of very unique circumstances where it may be allowable to use those data elements. So those data elements get the highest level of scrutiny. And that's all related to disparate treatment. In terms of disparate impact, there are a couple of things that happen. One is there are a lot of heuristics that have developed over time that model developers pay attention to when they're developing these models. And these are the things that I talked about in the past, right? So for example, they would put shape constraints on account age, because we know that account age is actually going to be correlated with the individual's age, or the history or the length of their credit history is going to be correlated with the age of that person. And so you can put some shape constraints on it, make sure that it's not disadvantaging senior citizens and things of that nature. There are things that you can do with regards to treatment of missing values. So for example, if a model is looking at delinquency on mortgage loans, you want to make sure that such a model is not disadvantaging the renters relative to the homeowners, because renter versus homeowner could potentially have a disparate impact. And then when someone is looking at credit limits or DDA balance or something like that, then again you want to make sure that you're not sort of binning at very high values, because then it becomes kind of like a proxy for income and things of that nature. So there are all kinds of heuristics that have developed over time that people can that model developers can use to avoid disparate impact from their models. And then once a model is developed, it's tested by the legal and compliance teams. These are separate teams. They are independent from the model development team. They do have access to protected class data, which again, as I said before, model developers don't even have access to that data, but you need that data to do the testing, to figure out whether or not there's potential for disparate impact. And these are totally separate teams which are trained in legal and compliance matters, who do the testing. They calculate the disparity metric. if the disparity metric is above a certain threshold, they would work with the development team to evaluate alternatives like dropping a variable or moving certain cutoffs and try to find acceptable solutions. So that's kind of the part of the model development process. And then periodically, once the model has been deployed, there would be further testing of potential disparate impact and sort of trying to do root cause analysis and so on and so forth. So there's actually a pretty large infrastructure that's going to exist in most banks that tries to prevent any potential disparate impact and then monitor for it, because it is the law, right? I mean, the bank can get sued. They can sort of be, the regulators can come after the bank. So this is kind of a big deal, and the banks tend to take it very, very seriously. Now, when you look at some of the, so I'm going to move on from current practice to the emerging ideas that you see in literature. And some of the ideas that are emerging in literature are simply going to be unworkable in a practical setting, right? And before I get into why they're going to be impractical, let me just kind of give an overview of what these techniques look like. Techniques to prevent unfairness or mitigate unfairness in models. And I would put them in sort of three buckets. There is kind of the pre-processing techniques. There are techniques that are used during the model development, and then there are techniques, sort of post-processing type techniques, once the model has been developed. And so, the pre-processing techniques would do things like suppress protected variables, which makes total sense and is used in banks as well. They might do some reweighting based on protected class information, or they might do some adjustment of dependent variable used on protected class variables. That is extremely risky, right? I mean, the law explicitly prohibits the use of protected class information for model development, for credit decisioning. And if you start using the protected class information to reweight the data or adjust the dependent variable, it seems very, very risky, and most sort of legal and compliance team would feel extremely uncomfortable with that. The second step is model fitting, and this is where you can sort of do constraint optimizations by putting a constraint for fairness, or you can do a penalized optimization by putting a penalty for unfairness. You can even do some hyperparameter optimization, keeping fairness in mind, and so on and so forth. So you basically just, in addition to the predictive performance objective, you introduce another objective or constraint as part of the development process, and use that to guide either the fitting itself or the hyperparameter tuning, one or the two or both. And then the final bit is, once the model is developed, you can sort of do some post-processing on the model. And the thing that's kind of been suggested quite a bit is to have different thresholds, right? So you have a score from 0 to 100, and that score has disparate impact. If you use a constant cutoff, you say, okay, everyone above 70 is going to be approved. That has a disparate impact. So you can change that 70. Instead of applying a uniform 70 threshold, you can have different thresholds for different protected classes to sort of try to reduce the disparate impact. Again, something like that would not be allowed, or would not be allowed at all. I mean, it's a theoretical approach that's out there in literature, but something like that would simply not be allowed under sort of current law, and cannot be used in lending. So you have kind of current practice that most banks are using that's meant to prevent disparate treatment and prevent disparate impact. And then you have all these new ideas that are coming up, and some of them sort of more very, very explicitly use protected class information, which is simply not allowed. So there's kind of a conflict between the two. And what's promising is that there's a potential middle ground. And I've seen some interesting papers come up where the protected class attributes are not used explicitly in terms of reweighting the data or changing the thresholds, but that perhaps they're used for variable selection or hyperparameter tuning, which is not that different from what's happening already, right? I mean, if you think about the interaction that's happening between the model development team and the compliance teams that I just described, where the model development team develops a model, and then the compliance team tests the model and gives feedback, and that sort of back and forth, you can kind of try to put all of that back and forth into a framework in a more sort of automated sort of a framework, which focuses on hyperparameter tuning and variable selection. And I've seen some interesting approaches there in terms of trying to do that a little bit more efficiently and in a streamlined way. And it'll be interesting to see how some of those things evolve and how sort of they're reviewed by legal and compliance teams in the various banks. So with that, I will take a pause, and I just try to cover the whole landscape and give you a little bit more context on the actual practices that that people use, especially in the lending use case. The technical details, like I said, you can go to the paper and you can go to some of the references in the paper and you can find a great deal of information. Hopefully, this was helpful for people, and I'm happy to sort of have further discussion. We have a few more minutes to do that.
Yeah, thanks so much, Harsh. This was very enlightening, especially some of the pragmatic challenges which you have to face as you kind of deal with um, little regulation or little regulatory guidance at this point, at least, and also with a lot of frameworks. I mean, as I kind of see the tooling chain and the ecosystem grow, especially with all the algorithmic auditing related stuff associated with fairness, and especially with some of the focuses on other kinds of algorithms, not primarily in the banking industry, like hiring algorithms, facial recognition algorithms, especially with the successes in computer vision, and what does it mean to adopt these systems when large segments of the population are potentially going to be expected to use these. I mean, they may not have a choice. Now, how do you see this evolve? Because many a times you cannot generalize things unless you contextualize it for specific domains and specific problems, right? And then we are also in some way kind of taking what we are as a society and what fairness means in the decisions we make, and we are trying to teach these to machines, and we are trying to also build in the gating process and the guardrails. So there is the what you call the uber goal of basically kind of being having like being on the pedestal and saying this is like the standards for fairness which we all want to adhere to, but we don't have the data. I mean, like if you look at historical data, biased decisions are already in place in various
Yeah.
questions, and you kind of teach machines in some way to make those kinds of decisions. So there is obviously the learning aspects and the pipelines, but there's also the guardrail. So what segments, how do we kind of look about continuously learning? Should we think about human in the loop more? Should we think about more rigorous guardrails? Should we think about more explicit specification and transparency, disclosure, and accountability related aspects? So how do we see the area evolve? Obviously, there's a lot of interest in AI. So what would
Yeah.
be your thoughts?
Yeah, I mean that's a pretty broad question, and a couple of things. We'll have to work on all of those things that you mentioned, right? We have to work on all of those levels. One of the things that I like about how fairness framework is set up for lending is that focus on demographic parity. I think that's great because it's not impacted by sort of unfairness in the ground truth. It doesn't care about the ground truth. It's just saying, I want you to approve a similar proportion of loans for similarly situated borrowers in different demographic groups. I don't care what your model tells me, right? So I think those things, from that point of view, there are certain fairness metrics that will provide more protection against sort of biases in sort of the ground truth and so on. So we need to think about it as and I think it has to be industry by industry, right? I think it has to be use case by use case. People will need to figure out what's the appropriate definition of fairness, what is the appropriate fairness standard of fairness that each use case needs to apply. I suspect there'll be regulators that are aligned to each use case. So for financial use cases there is CFPB, right? So someone like CFPB would probably take the lead and provide more guidance that goes beyond what the law says, right? Because the law is sort of not black and white, and it
Right.
changes, and so the regulators will have to take a lead in in setting the framework and providing more clarity to the market participants so that they can do the right thing. And I do think the other things like disclosure and redress and being able to sort of challenge the decisions, those are going to be super important, because we can't assume that things will go right. Things will definitely go wrong. Every here and there, things will go wrong, and we have to build systems which are sort of not fragile. They don't sort of break apart. If there is a data error, oops, your whole life is kind of thrown for a toss, right? And that still happens. If you look at credit, the credit reporting agencies, their data has lots and lots of errors, and it's really, really hard to correct that data. But at least there is a mechanism, and we need to keep working on that, and we need to sort of make sure that that kind of disclosure and redress is there, and it is improving all the time, because mistakes will happen, and we just need to build a system that can work with mistakes.
Absolutely, absolutely. Now, I mean, when I teach some of these concepts to my students, the pragmatic aspect there is many students kind of look at it as like, okay, this is a peripheral issue. We want to kind of look at the algorithms. We want to look at the deep learning algorithms, the NLP algorithms, all the aspects which they feel are things which the industry wants in terms of skill sets. Now, how do you how do you recommend people approach this in the context of, because obviously there's a lot of literature which is being published on a daily basis on fairness, ethics, explainability. Multiple conferences are kind of focusing on these themes, but many of them are coming primarily from a theoretical perspective, and there is a lot of formalization on how do we define these problems and build guarantees and stuff like that. But the reality on the ground is many people who are going to be making these decisions or even adopting these models don't have the technical sophistication, and they may not even be able to interpret the results, even to specify the problems on like what are they looking for when you talk about fairness. So how would you bridge that gap?
Yeah, I mean, I think as individuals, as someone who's interested in learning, I think the important thing is just staying connected with the right sort of information sources, right? And one sort of tip I would give is, definitely follow some of the law resources, right? Because I think the quants tend to are still struggling with this a little bit, and especially the tech firms who are just starting to think about fairness, they are still kind of trying to navigate it. But the lawyers have been thinking about it for a very, very long time, right? So if you're interested, if you want to make sure that your information diet is sort of well diversified, I would say make sure that you have some lawyers in your LinkedIn, in your Twitter feed, and those sorts of things, and follow some of the legal resources that are thinking about it. But on the flip side, from an organization's point of view, I think all organizations need to have some kind of a framework to manage the ethics of AI. I think it's going to be very important. And if they are impacting people's lives, if they're impacting their employees' lives, they need to
Mm-hmm.
have a framework. And I don't think there's a one size fits all. For some, it may just be like an ethics board, and that's it. Versus for banks, there are multiple lines of defense. You have, we talk about three lines of defense: the model users, the model, independent risk management and audit. And so there's like this huge infrastructure of risks and controls that's set up behind it. So I'm sure different organizations will land at at sort of different solutions, but they need to kind of have a thoughtful conversation about it, right? I mean, I think the boards and the CEOs should be thinking about it. What is my framework, right? And it shouldn't be that it's an afterthought. It should be something that they're constantly thinking about it and planning for it, because it's a very important issue, right? And basically what we are doing is, over time, we're going to be replacing human beings making important decisions with algorithms making important decisions. It's a huge thing, right? You can't kind of treat it just as a software problem. It's much more than that.
Absolutely, absolutely. And I think it's an ongoing discussion. I know we did try to get to many of the questions, but we still have some comments and questions still there. I tried to skim and combine certain questions so that we could basically do some dimension reduction, if you will. in terms of embeddings for the words, which many people have been trying to use in their questions. But this was a fascinating session. Thanks so much. And for people who are listening in, I put in the link to the paper in the chat window. And you could also just Google, Agus and Harsh and Wells Fargo, and Wells Fargo Group has been, publishing a lot of papers associated with explainability, bias, and various themes. I really encourage you to take a look at some of the research and also some of the white papers that have been publishing. So Harsh, let's continue the discussion offline, and I'm going to be posting the video and some of the links you provided to the audience. And next week we have Umang Bhatt, who is from the University of Cambridge, and he also has multiple affiliations with the Partnership of AI and a couple of other organizations. So he's going to be talking about this whole notion of uncertainty quantification in machine learning and also explainable AI. So he's been writing a couple of posts, and I got to know about his work, about one of the papers he had written, and also IBM released an uncertainty quantification toolkit. So I think there is a pragmatic aspect to how you can potentially use it, but also some of the theoretical aspects. So please join in next week on Tuesday at 12 o'clock. And as always, the link to go and register is Q Summer School 2021 .splashthat.com, and if you just Google us, you'll be able to find the links. So thank you again for joining today's session, and I hope you have a wonderful rest of the week. And thanks so much again, Harsh, for this enlightening session.
Thanks for having me.
Thank you.